Today we are going to do section 7.6 on page 736, Matrices. The Matrix is the name of a famous movie that is very cool, okay? And but unfortunately, the real matrix, as defined in math, is the exact opposite of that, and you will find that out in a second. Now, first, let's say what it is, okay? On this page, you see several matrices. The matrices are just a pack of numbers arranged in a rectangular shape. That is, for example, at the top of page 736, we have A, and you have that's one matrix, that's a 2 by 2 matrix. B is a 3 by 3 matrix, and C is a 3 by 2 matrix. The first number refers to the number of rows in the matrix, and the second number refers to the column. So if a matrix, for example, the matrix C in this example then has, let's see, it has 3 rows and 2 columns. And the matrix B is a 3 by 3 matrix. It has 3 rows and 3 columns, and so on. And sometimes you can have, for example, a matrix with only 1 row. That's a 1 by 3 matrix. It has 1 row, 3 columns. And down here, this is a 3 by 1 matrix. That is, it has 3 rows but only 1 column. Most of the time, I think we use the matrices that are even, that is 2 by 2 or 3 by 3, that sort of thing. And so those matrices are then a rectangular arrangement of numbers. And what are we going to do with them? First, let's look at example 1, okay? The example 1, we have a matrix, and the matrix each number in the matrix has a specific name. They're called entries. Now the dimension of this matrix is a 3 by 3 matrix. Now what is the number at A31? That means it's at row 3 and column 1. Okay, in this case it's the number 3. At A22, then is row 2, column 2, and that's the number 4. As you have, so yeah, so it's, see, row 3, which is 3, as the book says. So please do this example 1 yourself also, okay? It's just a matter of familiarizing yourself with the terms and remembering how to count, which one is the row and which one is the column. It's fairly obvious, but sometimes you might confuse the row with the column and then you got the wrong answer. That happens to me more frequently than I would like to admit. So next, let's turn to the next page, page 737, and consider how to add matrices. Now, to add matrices, first the matrix has to be the consistent in shape, in dimensions. That is, if these are 2 by 2 matrices, and if they're the same dimensions, then you can add them up, and you will add them up by adding each corresponding term. That is, in this matrix, you add A to C and C to G, and so on. That is, each one's position will add to its corresponding position in the other matrix, being that the matrix has the exact same dimension. And so things have just been added like that. And so that is how you add any matrix, as long as their dimensions are the same. If the matrix has a different dimension, then you cannot add them up, because how would you do that? Okay, there will be a bunch of entries that you don't know who to add it to. But as long as the matrix has the identical dimensions, then you can just add them up by adding each corresponding entry. Okay, A11 will be added to the other A11, and so on. Or the other one might be called B11. Anyway, the entry at location 11 will be added to the other entry at the location 11, and so on. And so please do example 3 by yourself, okay? Just, it sounds tedious, and it is, because what that means, this is only a 2 by 2 matrix, and to do this sum, you have to do 4 additions to get there. You know, not very exciting, but that isn't a big deal yet. So next, let's turn to page 708 and look at example 4, where we calculate differences of matrices. That's the same thing. When we take a matrix minus by another one, first they have to be the same dimension. And once that dimension are the same, then each entry will be subtracted by the entry item in the corresponding position. Like in this example, then -2, at the 1, 1 position will be minus 2, then -8. And then 0 down here will be -5, and so on. So you do 4 subtractions, and then you get some kind of an answer, which doesn't sound too bad, but then imagine you do 3 by 3, then you have to do 9 subtractions, and 4 by 4, you have to do 16 subtractions. Yeah, I don't, I'm not good for that kind of thing. But anyway, so please do that yourself, okay? So that you have, you get a feel of how to mess with this stuff. And then let's look at example 5, where you are supposed to have, we got 3 by 3 matrices. We're given 2 3 by 3 matrices, and you're supposed to find the sum and then find the difference. You just take each term, okay, each corresponding term, and then add or subtract to its copy, its location. See, 2 will be add or subtracted to 6, and 14 to 0, and so on. And finally, this 2 here will be add or subtracted to that 2. So everything will be add or subtracted depending on what you're doing, to its corresponding partner, so to speak. And then that will be the answer. So in this case, then you have to do 9 addition or subtraction to do this example. So please do this yourself, okay? And this is still not so bad yet. And so next, let's go to the next page, where we have where is it? Okay, let's go to page 740. Okay, flip over and get to example 6. In example 6, where we have the concept of a matrix multiplied by a regular number. When it comes to matrices, the regular number is called a scalar, okay? The word scalar just means it's not a matrix, it's just some number. Like in example 6, this is the number is 3, okay? The so-called scalar, which is just a non-matrix number, a regular number, that is. What happens when you take a scalar multiplied by a matrix? That you do that by taking that scalar and multiply by every single entry of the matrix. That is, 3 will be multiplied by 8, by 5, by 1, and by 4. See, show it here. And so you do multiplication 4 times. Every single thing gets multiplied. And when you do it, the answer will be the matrix of a scalar multiplication. And that is example 6. Please do that yourself. Okay, and next, example 7. And this is a mixture of scalar multiplication and addition, or subtraction, doesn't matter. So when you do that, you do it like you would imagine that it's done. So what you do, let's say we have A and B, and we need 3A plus 2B. So to do that, first you take 3, multiply by every single thing in A, okay? And that gives you a new matrix after you do multiplication 9 times. And you do the 2 times B the same way, okay? And then you add them up, see? So yeah, on the next page, you do the 2 times B, okay? That gives you another matrix. Then you add them up, entry by entry correspondingly. And after you do, I don't know how many things you've done, okay? That's 18. And then that's 27 operations. If you do all 27 operations and don't mess up, then you will have the right answer. If you do mess up, please find a mistake and fix it. That's all there is to say about that. Okay, so now that we have said that, the next thing is, now all that you might think, that's not too terrible, right? Yeah, it isn't. The next thing is called the product of 2 matrices, and that's where life gets really terrible. Okay, so to do that, let's look at example 8. So let's look at example 8 on page 742. I have written down, copied down here, matrix A is 1, 2, 3, 4, and matrix B is 5, 6, 7, 8. You can totally tell that they just made this up, right? And so how do you multiply 2 matrices together? Now this is not scalar multiplication. Scalar multiplication, as we mentioned before, is if you have a number multiplied by a matrix, then you just take that number and multiply by each number in the matrix, then you're done. But how do you multiply a matrix with another matrix? Okay, now that follows a very specific rule, which is called row times column. What does that mean? That means the first row will be multiplied by the first column, and the result will be written in their intersection, like this. Okay, when the first row, well, anyway, so I'll just do this for you. That may make better sense. So what happens is we need to take the first row multiplied by the first column. Okay, what does that mean? I'll write down the answer here. A times B equals to, first row is 1 and 2 times 1 and 2 has to be multiplied by 5 and 7, which means 1 has to be multiplied by like this. Okay, watch my finger. It's going to line up this way. That is, 1 has to multiply by 5, and 2 will multiply by 7. And after you do that, you will add it up. That is, the first entry is 1 times 5 plus 2 times 7. That's just the first entry. Okay, and after you figure out what that is, then you do the second. The second entry is the first row and times the second column. Well, we'll do this one. Okay, that is the first row times the second column. They intersect at this? See, the first row and the second column intersect at this location. So the answer will be written here. Let me move this over a little bit to give us more space. So the first row times the second column, which means 1 multiplied by 6 and 2 multiplied by 8. Watch how my finger goes from row to column to match up. Okay, 1 will multiply by 6 and 2 will multiply by 8. So the second entry is 1 multiplied by 6 plus 2 will be multiplied by 8. And then the second column, okay, the second column multiplied by the first row. The row and column intersect at this point. Okay, that is, their common point is right here. So then we have 3 multiplied by 5 and 4 multiplied by 7. So down here we'll do 3 multiplied by 5 plus 4 multiplied by 7. So the row, see, to get to any, and finally the last one, the row 3 and 4 will be multiplied by 6 and 8. 3 will multiply by 6 and 4 will multiply by 8. So the last one is, I said 3. Let's see, 3 will multiply by 6. Okay, so 3 multiplied by 6 plus 4 is going to be multiplied by 8. All right, so once we do that, then I'll write down the answer over here. Okay, now let's do this stuff in our head or in the calculator. The calculator is probably more accurate, but I'm going to try to do it in my head just because I don't want to bother with the calculator. Let's see, that's 5 plus 14, let's say is 19. This one is 6 plus 16 is 22. Next, 15 plus 28, 15 and 28, that's 43, let's say. And finally, that's 18 times 32, that should be 50. Okay, so that is how you multiply two matrices. The multiplication has to be done in such a way that the row has to be the same. There's a size requirement that, but I'm not going to even think about that right now. Right now, I just want you to memorize. The row has to be multiplied by the column, and wherever their location intersect, that you see their common location is this spot, right? And that is where you write the answer. See, and then this row multiplied by this column, then their common location is this spot, and then that's where the answer goes. And you keep doing that, and then you get some kind of an answer that, if I'm not messed up, if I didn't mess up, 19, 22, 43, 50. Aha, I got it right. So then, so that is the answer of the matrix A times matrix B. Now this is a 2 by 2 matrix, which isn't too bad, okay? As you can imagine, this job gets much worse the bigger your matrix gets. But it doesn't matter how big it is, by principle, it can be done. That is, given yourself enough time and patience, you can multiply two matrices together regardless of how big it is. It just takes, a long time to do all this multiplication and addition. But once you grind through it, then it's done. Right? Anybody who can do multiplication and addition or subtraction, if these numbers are negative, then you might be doing subtraction. Either way, the point is it can be done. You just have to memorize. When it comes to multiplying matrices, is row times column, and then you have to remember their answers written where the row and column intercepts. That is what is common for both, because a row and a column only have one common location, and that's where you write your answer. And but to me, this process is very error prone. Okay, and then yeah, so that's example 8. Please do the example yourself. Okay, repeat this process and make sure you know you memorize the row times column principle. The matrices are extremely important. Okay, as much of a drag as they unfortunately are extremely important and useful. So it's important for you to know how to do this. And it doesn't take much, really, as long as you remember. It's row times column. All right, so next let's look at example 9, the same thing, okay? We'll take, what are we doing? We are doing A times B and then B times A. Right. So then, so what you do is, and notice that well, anyway, the question then you might ask yourself if, actually let's not ask ourselves anything right now. Let's just do this, okay? So then to do A times B, what you're gonna do is take 1, 2, 3 and multiply it by 5, minus 4, and 2, respectively. Okay, 1 will be multiplied by 5, and row times column. So then, and then you add it all up once you do that, and that gives you the answer in their intersection. Where do they intersect? They intersect at location 1, 1, and that's your answer. So as a result, when you take A times B, A is a 2 by 3 matrix, and B is a 3 by 2 matrix. Your answer is going to end up being a 2 by 2 matrix by the time you're done, because you're doing row times column, so there's only enough stuff to do 4 times. This is it. Okay, so please do this yourself, and as you practice memorizing row times column, because there is no getting out of doing matrices, really. So, and after you do A times B, then you're gonna do B times A. And as you notice, you follow the same rules, okay? The row times column, except the row now has only two things, times column is 2 things. So your math comes out completely different. And not only that, even your resulting matrix is a different dimension, because the other one become a 2 by 2, and this one turned out to be a 3 by 3. That's just how it works out, because you're following the rule that's called row times column. So you take each row here, multiply by each column, and write down some answer, and you keep doing that until you come up with something like this. Maybe I should do this one. Yeah, I think I will. I'll do and I will do the second part of example, what is this? Example 9. I'll do example 9b. All right, now I'm gonna do part B here, but be sure that you do part A yourself, following the book's directions if you have any problems. You just have to remember the row times column principle when it comes to multiplying matrices. So we have A equals minus 1, 2, 3, 4, 0, 5. B is 5 minus 1 minus 4, 0, 2, 3. All right, I think I copied it correctly. So we're going to do B times A, okay? B times A. What is B times A? We're going to, that would be, well, whatever. That equals to, okay? We'll take the row here times the column here. So 5 and minus 1 will be times minus 1 and 4. So 5 times, that is very, very easy to get confused, I think. But anyway, but if you focus carefully and stand by the principle, first row times first column, okay? We're doing B times A, so B comes first. So B is the ones that we do the rows of. So row times column, we have 5 times minus 1, that's minus 5. And then minus 1 times 4 is minus 4, okay? And then, so next, minus 4 and 0 times, this is the second row, and then times the first column, so the answer will be written here. All right, so yeah, and let's see. So minus 4 times this is, minus 4 times minus 1, that's 4. And then 0 times 4 is 0, so we only have 4. Third, this times that, so the third, 2 times minus 1 is minus 2, and 3 times 4 is positive 12. So far I've done 3. So we have this one times this one, give me the first answer. The second row times the first column. We're still doing the first column, okay? So give me this answer. And the third row times first column, it gives me the third answer. So, and we will continue to do this. All right, so next we'll take the first row, we'll work on the second column. So first row, second column, that gives us, yeah, pay careful attention. First row, that's 5 times 2 is 10. And then 0 times minus 1, 0. All right, so then second row times the second column is minus 4 times 2 is minus 8. And then the 0 will make it, we don't have to worry about the 0. Okay, then, and then the third times this one is 2 times 2 is 4. All right, so that's good. And then finally, the third one, we're going to work on the third column. First row times third column, 5 times 3 is 15, and then minus 5. Okay, minus 1 times 5 is minus 5. Secondly, the second row, this thing times minus 4 times 3, that's negative 12. And then finally, 2 and 3 times 3 and 5, 2 times 3 is 6. 3 times 5 is 15. All right, so that is our answer. If but we have to finish the calculations. So that the answer then should be, let me check by now, make sure I got it right, and that I didn't mess up. Okay, the answer should be minus 9. That's so far so good. Okay, minus 9. From there, 4. That's good. Minus 2 plus 12, that's 10. Okay, I'm correct so far. 10. Okay, next, that's 10. That's correct. Minus 8. Okay, and then 4. All right, and finally, that's also 10. And then minus 12. And then finally, 6 plus 15 is 21. Yeah, so. Wow, check this. I didn't mess up. But that's because this is a fairly easy multiplication because I'm doing the two things being multiplied. So I mean 2 things being added together, right? So if I had more, I have a feeling that would have been doing much worse. But anyway, so that is how you do part B. And so each row, the row from the first first item in your product will have to be multiplied to the first column of the second product. So the first matrix, you only can do work on the rows, okay? And the second, it matches to the column of the second matrix. You always, that is, you don't care about the columns here, right? If you're multiplying this way. And then, so anytime, so the multiplication, what you're doing repeatedly, okay, endlessly, let's just say, well, maybe not quite endlessly, but feels that way, is you're always doing row times column, okay? And then write a result where this is where the row and column intersect. That is, this is the first row times the first column, first row times second column, and first row times third column. And that is, well, something like that. I mean, it's and do the columns even intersect? I'm not sure. In this case, where do they intersect anyway? I don't know. But the point is, you take the row times the column, and then you follow it down in that way, like this. Well, anyway, so yeah, so the first row times first column, the answer will be at the 1, 1. First row times second column. Yeah, well, anyway, you get the idea. I can't remember the details of how this is explained, but that is how you multiply the stuff. You multiply the row and then times the column, one at a time, and then work your way down. So then the first row times first column, your answer will be in the first row, and then second row times the second column, and times the first column, then you'll be in the second row, first column location, and so on. Something like that, okay? So please do this yourself, then you will get a feel of what I'm talking about. So, and we have come to the end of this section. We're going to skip example 10 and 11 because I feel that they're irrelevant for now. So let's, for homework then, on page 746, please do problems 7, 15, 19, 25, 31, and 51. They are, well, doing basically what we've been doing so far, and that's all I require from that you do. All you need to do this is just remember how to do things, like how to add matrices. That's not so bad. Subtracting, the same idea, and then multiplying by a scalar, which means just a number that isn't a matrix, and that is still not so terrible, okay? And then you multiply by each item, okay? But then the hardest part is multiplying two matrices together, and so I ask you to do a couple of those, and then and then if the matrix dimension don't match, that is, you have to, when you multiply or add or do anything, you have to have the right number of stuff to add. So if the two matrices are the wrong shape, like one is too much bigger than the other, for example, then you can't, there's not enough stuff to add. Each item has to be added to the next item. And then in that case, the matrices cannot be added or multiplied or whatever. So please go do your homework, and when you're done, I want to talk about problem 51. So now that you're done with your homework, let's talk about problem 51, the most tedious problem in this section. Well, not the most, but one of the most. And so let's, do this by following the principle. I forgot to write down the principle. So here we're trying to calculate the matrix B times A, and to do that we're going to follow the row times column principle. Okay, there are three things which I think I'm just going to pull out my calculator to do this. All right, so the first thing we're going to do is this three items will be multiplied by, this is the first row, will be multiplied by the first column, okay? 0.5 will be multiplied by -2, 3 multiplied by 1, and 0 multiplied by 0.5. And then once we get that all sorted out, then we will write down the answer somewhere in the first location. And we'll continue doing that until we do 9 things, and yeah, so that's what I'm going to do, okay? And let me turn. I'm just gonna do this with a calculator. So the first row times first column means 0.5. I'll just write 0.5. Okay, 0.5 times -2 plus. Yes. Okay. Plus 3 times 1, that's just 3, plus 0 times 0.5, we can skip that. So that will be 2, and I'll write that down equal to 2. So we're done with one thing. Okay, 8 more to go. First, then we're going to do the first row times the second column. Okay, that is the 0.5 will multiply by 0, 3 will be multiplied by 8, and then 0 multiplied by 4. So that this multiplied by that this way. Okay, the row will lean over and match with the column and multiply each term. And so then we have first row by second column, 0.5 times 0, we'll ignore that. And then 3 times 8, 24. And then 0 times 4, is, again, we can ignore that. So we will just have 24. That's it. So that's the row times column that end up in this location. So that is the first row, second column. So the answer will also be in the first row, second column, which is 24. All right. So, and next we will have first row, third column. Okay. So we'll have 0.5 times 9, 3 times minus 3, and 0 times 5. So first row, second column. And so let's do that. We'll have, let's see, 0.5 times 9 times 9, and then plus 3 times minus 3, that's negative 9. And then 5 times 0, we can ignore that. That equals to minus 9 halves. All right, we'll write that down. And that's minus 9 halves. So far we have 6 more to go. And so we're completely done with the first row, okay? The first matrix will only care about the rows. The second matrix only get the columns. So we're done with the first row. So let's start with the second row. So the second row, 3 things. Second row times first column, the answer will be in the second row, first column position. So minus 4 will be multiplied by minus 2. So that's positive 8. And then 1 times 1, okay, that's 1. And then 6 times 0.5, that's 3. So that gives us 12. So I'll write down 12. Okay, now we are 4 down, 5 to go. So next, the second row multiplied by the second column, we have minus 4 times 0, that's 0. 1 times 8 is 8. And then 6 times 4 is 24. Oops. So that gives us 32. So let's write that down, 32. All right, next. The second row times third column. Okay, the answer will be in row 2, column 3. Sorry, I kicked the camera. Okay. And anyway, let's see, what was it? Second row, third column? All right. So that gives us minus 4 times 9, that's negative 36. And then 1 times minus 3, that's minus 3. And then 6 times 5, that's plus 30. And that gives us negative 9. Yeah, okay. Next. Okay, we're done with the second row, and then so we'll do the third row. So the third row will be multiplied by first column, and then the result will be in row 3, column 1 of the answer. So just for, see, row 3 multiplied by column 1 end up being in row 3, column 1. It follows the pattern, so that make it easy to remember. So 8 times minus 2, that's negative 16. And then 7 times 1, that's 7. And 2 times 0.5, that is 1. Okay, that gives us negative 8. Okay, minus 8. All right, next. Second row, third row, second column. Okay, so this is third row, second column. 8 times 0, that is 0. And then 7 times 8, that's 56. And then 2 times 4 is 8. That gives us 64. Okay, one more to go. And lastly, bottom times, yeah, anyway, so 8. Third row, third column. The result also goes to third row, third column. So the third row times third column, let's multiply that out. 8 times 9 is 72. Plus 7 times negative 3, that's negative 21. And then plus 2 times 5 is 10. Okay, that gives us 61. And then that means we're done. Okay. And right now, the 61, the only thing to do is to check to see if I got this right. Did I even check to see if I copied down the problem properly? I think I forgot to check. But yeah, if I mess up, we will find it. So anyway, so that is my answer. Let me see what, let me check to see if this is correct. All right, I found the answer. It says 224 negative 4.5, 1232 minus 9 minus 8, 64, 61. I got it right, see? So then in this section, the only thing you have to remember is to multiply two matrices, it has to be row times column. That is, the first matrix row will be multiplied by the column, the second matrix column, in that order, okay? The order matters greatly, which is why I wrote this thing in front of this thing. The shifting the order will often give you a completely different matrix, or you can't even do it, okay, depending on the dimensions of the matrices. So row times column is something that you need to remember from this section. And with that, we're done, okay? Because I'm not assigning a lot of homework because there's no need to do any more of this than absolutely necessary.